Okay, so now that we know how to complete the square and use the quadratic equation, use discriminants, we need to talk about how to actually graph these parabolas. As we've mentioned before, anytime we have a quadratic equation, we need to remember that it's a parabola, and more importantly, now we need to be able to graph this parabola. Now there are two forms. The book, if we had a book, would give you this form, and I know this is a little vague right now, but we'll explain it. The more important or more common form is to add this k to both sides and say y equals a x minus h squared plus k. And again, I know that doesn't make a lot of sense right now, but the key here, we have a y equals. And why do we have y equals? Well, on your calculator, anytime you graph, it needs to be y equals. So that's why we move to k to the other side. One thing we do know is the vertex of our parabola is given by the coordinates h and k. And the vertex is the bottom or the top, depending on which way the parabola opens of the parabola. So the vertex would be our blue points there, and they're given by the coordinates hk. Let's do some numbers in here. That'll make this a lot easier to understand. I'm going to give you three equations. So remember our formula a x minus h squared plus k. All I want to do is change our numbers for the letter a. What if we had 1 parentheses x minus h squared plus 0? What if we had 2 x minus 0 squared plus 0? And what if we had negative 2 x minus 0 squared plus 0? And I'm going to color these equations. I'm going to make this one blue, this one red, and this one green. And what we notice is we can simplify these drastically. This top equation is just x squared. This middle equation is 2x squared. And the bottom equation is negative 2x squared once we simplify all those zeros. Now what happens when we graph these three equations? Well, this is our graph of the red, the blue, and the green equations. And what we notice are two rules that we need to remember anytime we're graphing. The first rule is that if a is positive or greater than 0, our parabola opens up. So that means, again, this one opens up and this one opens up. So the opposite, if it's negative or less than 0, it opens down. And if we go back to our graph, our green parabola is opening down because it's a negative 2. If a is negative, it opens down. Our second rule is that as the absolute value of a increases, notice here it's a 1 and here it's a 2, the parabola is more narrow, so it narrows. As the absolute value increases, so from the blue to the red, again, when we go from a coefficient of 1 to a coefficient of 2, which is greater, look at the blue and the red charts. The red is narrower. It's a narrower or a smaller parabola in a way. All right, and those are our rules about A. Now let's look at some examples for h and k. So if we had x minus 2 squared plus 2, where would the vertex be? We said our formula is ax minus h squared plus k. The vertex would be at 2, 2. Because we see that h is at 2. Notice we don't care about that negative because that's part of our formula. So that's where this 2 comes from. And k, our y-coordinate of our vertex, would be at positive 2. So at the very least, if we had to graph this parabola, we know the vertex is at 2, 2. And because a is a 1 or positive, we would know this parabola would open up. What if our equation, let's go to a new slide, what if our parabola was x minus 3 squared minus 1? Where would that vertex be? This vertex would be at 3, negative 1. So we would go 3 right, 1 down. That would be our vertex. And this parabola would also open up. What if our equation was y equals x plus 4 squared minus 2? Now this is probably the trickiest way they can do it, because remember our formula is x minus h squared plus k. And we're looking for the coordinates of our vertex. Now it might be easy for you to see that k is negative 2, so we know we'd have to go 2 down. But what about the x coordinate? And if negative h is a positive 4, that means h is actually a negative 4. So we would go 4 left, and my vertex would be down there. And again, since our a is just a 1, this would open up. So it's very important for us to know where our vertex is. Let's do one more quick one. What if it was x plus 3 squared plus 1? Our vertex would be, and again, the y-coordinate is probably the easier one. My x-coordinate, if my formula is x minus h squared, would be negative 3. So my vertex would be at negative 3, 1, and it would open up. Whoop, like that. A couple other things we need to be able to do. We're going to talk about an axis of symmetry. And you can see this. Every time we draw a parabola, doesn't matter where, it looks like there's a mirror in it, right? Or if we folded a piece of paper, whatever's on one side is on the other. Now we know the vertex has the coordinates HK, and H is the x-axis, so we know that H equals X, whatever number is the x-axis of the vertex. What if I asked you to find the x-intercepts? Or where our parabola cross the x-axis? That's easy. Set y equal to 0 and solve. What if I asked you to find the y-intercepts? What's the exact opposite of the x-intercepts? We would set x equal to 0 and solve. So let's do some numbers and you'll understand exactly what it is we're talking about. Here's an equation. Example 1. Y equals x plus 4 squared plus 3. Every problem is going to ask you the following list of things. First, we need to find the vertex. And we know that that's HK. And in this problem, that is -4 and 3. Again, because of our x minus h squared plus k formula, our vertex is -4, 3. So if we had to graph this, 4 left, 3 up, there's our vertex. Next, axis of symmetry. And we will abbreviate that axis of symmetry, AOS. And I just told you that in the last slide, for the axis of symmetry, x equals h. What does h equal? -4. So let's draw that with a dash line. Everywhere that x equals -4, bam, did that. All right, let's do the next part. We need to know which way this opens. Well, we look for A, the number in front of the parentheses. In this case, that's 1. That's positive, so it opens up. So we know that's my parabola. All right, so now we need to find the y-intercept, and this is actually going to take a little bit of math, so let me go to the next slide. Y equals x plus 4 squared plus 3. To find the y-intercept, we let x equal 0. So put in a 0 and solve. 4 squared plus 3, that's 16 plus 3, that's 19. Go back to our equation, and it's going to be 0, 19. So what does that mean? It means way up here at 19, wherever that is, at the point 0, 19, that's where the parabola crosses the y-intercept. Now, I need you to think about this. And I will go to a new page. If my vertex is -4, 3, and my y-intercept is 0, 19, and we know that we have our axis of symmetry, where do you think the point straight across the mirror image point is? I mean, if we went from -4, if we go 4 right, that gets me to 0, 19. What would happen if I went to 4 left? What point would that be? Do you see that that's -8, 19? Okay, the next thing they're going to ask us is our reflective point. So let's think about this. Our vertex, we said, was at -4, 3. And I will put our coordinates there. And we just found that our y-intercept was at 0, 19. And we also have our axis of symmetry, which is like our mirror, at x equals -4. Now with all of that, can you figure out, if I were to do a mirror image of 0, 19 somewhere over here, where would that be? Well, we know that it would be 19 high because it's the same height, or up and down, as our blue point, our y-intercept. And what would the x-coordinate be? Well, if this one is 0, and the middle is -4, right, because this would be the middle, or -4, 19, then this point, if this distance is 4, this distance is 4, this would be at -8, 19. So now we know our reflective point is -8, 19. The last thing that these problems will ask us for is for our x-intercepts. And for our x-intercepts, we let y equal 0. So our equation was x plus 4 squared plus 3. Let y equal 0. That looks like we subtract 3 from both sides. That looks like we square root both sides. That looks like we minus 4 from both sides. So x equals -4 plus or minus the square root of -3. Or -4 plus or minus I square roots of 3. And that should make sense. Two imaginary answers because we have a negative discriminant and because our parabola never crossed the x-axis. So of course, if we had to put this into Canvas, this would be -4 plus 1.73i, -4 minus 1.73i. And those are our answers. And those are all of the things we will have to do for each problem. Let's try two more. Our equation, y equals -2x minus 2 squared minus 4. Let's go down the list. First thing we're going to need to do is to find the vertex. And this vertex is at 2, -4. And on your graph paper, we might as well graph that. 2, -4. Our axis of symmetry is just the x-coordinate of 2. And we can draw that by this vertical dashed line. We know that's sort of like our mirror. Next, we need to know which way does it open. Well, to know which way it opens, I'm looking at my number A, that's negative, so this parabola opens down. And I'll wait, but I know that it's going to open down a little bit, but let's see if we can find some more points to be a little bit more accurate. Next, we want to know the y-intercept, and to do that, we let x equal 0. I'm going to try to squeeze that in here. So -2, 0 minus 2 squared minus 4. That's -2 times -2 squared minus 4. That's -2 times 4 minus 4. That's -8 minus 4, and that's -12. So 0, -12. And that makes sense. because we know it has to open down. And now we just found that it would go to 0, negative 12. So that looks about right because it opens down. So again, if this is 0, negative 12, and this is 2, negative 4, where would my reflective point go? Well, I know it would be comma negative 12 down. What would the x-coordinate be? Well, from 0 to 2, then from 2 to 4. So my reflective point would be at 4. My reflective point would be at 4, negative 12. And the last thing we need to find is our x-intercepts. And we can see that it does not cross the x-axis, so we know we should get an I. All right, this problem should have an I in it. So I'm going to go to the next slide because I don't have enough room here. Y equals negative 2, parentheses x minus 2 squared minus 4. Let y equal 0. Add 4 to both sides. Divide by 2. Square root, that means we have a plus or minus. And add the 2 to the other side. Oh, there we go. So now we can see that we will have our I. 2 plus or minus I square roots of 2. And again, how are we going to write that in terms of numbers? 2 plus 1.41 I, 2 minus 1.41 I. And those would be our x-intercepts. So 2 plus 1.41 I, 2 minus 1.41 I. These aren't too hard, hopefully you're seeing that. And we will do one more just to make sure. Example 3. Y equals x plus 3 squared minus 2. Start off with our vertex. Negative 3, negative 2. 3 left, 2 down, vertex. Axis of symmetry. Axis of symmetry, x equals negative 3. Draw our dashed line. Find which way it opens. Look at our letter A. There is no letter A. That means it's a positive 1. That means it opens up. Figure out our y-intercept. Let x equal 0. 0 plus 3 squared minus 2 equals 3 squared minus 2 equals 9 minus 2 equals 7. So 0, 7. And we can graph that. 1, 2, 3, 4, 5, 6, 7 up there. 0, 7. Now we need to figure out our reflective point. And if our vertex is negative 3, negative 2, and our y-intercept is 0, 7, well, if we came over here somewhere, we know it would be 7 high. It's always going to be the same y-coordinate. What would the x-coordinate be? Well, this is a distance of 3. A distance of 3 more would be negative 6, 7. And the last thing is our x-intercepts. I'll go to a new slide because we're going to let y be 0. Add the 2 to both sides. do the square root of both sides, subtract 3. Now we can get some actual answers. And we get negative 1.59 and negative 4.41. Negative 1.59 and negative 4.41. And those are the steps for graphing our parabolas. We can actually graph this now, sorry. So we can find the vertex, axis of symmetry, which way it opens, the y-intercept by letting x be 0, the reflective point, and then the x-intercept by letting y equal to 0. Those are our 3 examples. Now you can do the worksheet.